Hello chemistry students, this is the video key on how to draw Bohr models. So this is a worksheet that is linked to our homepage in Canvas, and I gave you a little snip of the periodic table just so that you have it in case you're doing this and you don't have your laminated periodic table with you. So as you probably remember from class, the Bohr model has the nucleus of the atom that indicates the number of protons and electrons, and then in rings around the nucleus you are going to place the electrons. So the first thing to do when you're doing this type of problem is you have to take a look at the element and determine the number of protons, neutrons, and electrons. So in sodium 25, remember 25 is not the number of protons, that is the mass number. So remember that this is protons plus neutrons. And if you take a look at where sodium is on the periodic table, you'll see that its atomic number is 11. And that's going to tell us how many protons we have. It also tells us how many electrons it has. To figure out how many neutrons we have to subtract the number of protons from our mass number. So 25 minus 11 is going to give us 14 neutrons. Now in the past I've had you actually draw out the physical protons, neutrons, and electrons, but now we don't need to do that anymore. So now in the center of our atom we're going to just write P equals 11 for 11 protons and N equals 14 for 11 neutrons. Now I have to place my 11 neutrons around this nucleus. So I draw my first ring around the nucleus and I will put 2 electrons here. My first energy level, or my first ring, can hold a maximum of 2. But I still have 9 more electrons that I need to place. So I'm going to draw another ring, and in my second energy level, I can place a maximum of 8 electrons. And I still have 1 more electron to place. I can't just squeeze it in. I have to draw a third energy level. And in this third energy level, I will put my final electron. And that is the Bohr model for sodium 25. So some of these have different notations, and I just wanted to make sure that I do at least one example of each notation. I did already post the key to this worksheet in the answer keys link to our homepage. So for our next one, we have fluorine 22. And our bottom number is going to tell us the number of protons that we have, which is 9. So P equals 9. My neutrons, whoops, erase that. My neutrons are found by subtracting 9 from the mass number. So 22 minus 9 will give me 13 neutrons. And then the number of electrons, as always, is the same as the number of protons. So in my nucleus now, I'm going to write P equals 9 and N equals 13. And now I draw my first ring in which I place 2 electrons. I still have 7 more electrons to place, so I'm going to draw a second ring. I can have a maximum of 8 electrons in this second ring, so since I only have 7 left to place, then I know that they're all going to go in this ring. So one thing that I didn't do for sodium that I'm going to do here for fluorine is I'm going to place my electrons like so, putting 1 on each side of the nucleus and then going back and doubling up. And the reason to do this wouldn't be very clear to you right now, but when we start drawing electron dot structures in a few days, it will become more clear why you need to do that. So it's good practice to double them up like so in these drawings. And so that is the final drawing then for fluorine 22. Let's try one more. Let's try chlorine 33. So again, you need to find protons, neutrons, and electrons. And the protons for chlorine, I can't tell just from looking at the name here, but if I find chlorine on the periodic table, I can see that I have 17 protons because of the atomic number that I have there, and that matches the number of electrons. And then to figure out how many neutrons I have, I'm going to subtract 17 from 33, and that will give me 16 neutrons. So another way that you could designate the number of protons and neutrons in the nucleus is simply to write 17p for protons and 16n for neutrons. So either way is correct. I'm going to start by placing my electrons here. So my first two go in the first ring, and I still have 15 more that I need to place. So I'm going to draw my second ring, which is going to hold 8 more. All right. So now I'm full. I can't put any more electrons in that second ring. So in order to accommodate my last 7 electrons, because right now I've got 10, I have to draw a third ring. And now my last 7 electrons will go in here. There we go. And that is the drawing for chlorine 33. All right, chemistry students, hopefully this helped you out a little bit. Do check the key against your answers, and I'll see you in class soon. Thanks.